Moving on to example number 14, we are deriving 2 over the 4th root of 1 plus x to the 4th. This is going to work very much similar to the last example, but the last example was far more complicated, to be completely honest. But the idea remains here. The core thing that we want to worry about here is simplifying this enough algebraically before we take our derivative with using the chain rule, so that power rule becomes very easy to use in this case. So, as always, with basically anything you do in calculus, convert all of your radicals to a power first, okay? So let's convert all of our radicals to a power. That's all I'm doing in this step. So I'm taking my denominator, which is a 1/4 power, and applying that. And by the way, no, you cannot take that 1/4 power and cancel out the x to the 4th, nor can you distribute that 1/4 to the 1. Powers do not distribute over sums or differences. You have to FOIL. When you have fractional powers, you are basically stuck with whatever you have inside that fractional power. All right, so there's no cancellation that can happen here, I promise. All right, so don't try it. All right, so we still don't have enough leverage to derive this as it currently stands because we have all of our x stuff in the denominator. We can't use power rule when you have all this stuff in the denominator. You need it in the numerator. So what we're going to do is take that 1/4 power, negate it, and bring everything up to the top, okay? So that's our next step. We have d dx times 2 times 1 plus x to the 4th to the minus 1/4. You do not need to negate the exponents of anything on the inside of the parentheses there because the thing that's getting brought up is the entirety of what is inside the parentheses. So you just negate the big exponent, in other words, okay? Now, can we use the power rule? Yeah, absolutely we can. So our outside function is pretty clear. It's going to be 2 times parentheses to the minus 1/4. And then the inside function is, of course, the thing on the inside of the parentheses, as it almost always is. So you have 1 plus x to the 4th. All right, now let's derive this thing. Derivative of the outside, leave the inside alone, multiply by the derivative of the inside. So, derive the outside. You have 2, or minus 2, over 4, because I'm taking the exponent and I'm bringing it down in front and multiplying by whatever else is out there. So that gives me minus 2 over 4. Yes, that will cancel out to be minus 1/2. We'll worry about that later. Then you subtract 1 from the exponent. So that gives us minus 5/4, because you're subtracting 1 from minus 1/4. Be very, very careful with this. No, I can't tell you how many mistakes I've seen where people think that, oh, this is going to be positive 3/4 or negative 3/4. Be very careful about what you're doing with the subtraction, okay? So you have 1 plus x to the 4th and the inside. We're not done yet. We have to multiply by the derivative of the inside, which is obviously 4x cubed. Pretty straightforward. So the derivative is done at that point. Now we just need to algebraically simplify this a little bit. So the first thing I would do is I'd try canceling off this 2 and this 4, so I have minus 1/2. And then similarly, I have this 4 that I can multiply, so I'm going to take this and multiply it to this 4. All right, so I'm just combining my numbers. That's all I'm doing here. So I have minus 1 over 2 times 4, and that's just what happens when I simplified the minus 2 over 4 and multiplied by the 4. I'm not going to rewrite the rest of this. I'm just going to say, hey, look, I have minus 1/2 times 4. That's equal to minus 2. So minus 2 when you multiply those things out, the circled things. Now I will carry things along. I'm just trying to save some space and save you time. The 4 doesn't come along because we multiplied it to the thing in front. All right? Okay, so now we have a negative exponent to deal with. That means the thing with the negative exponent gets brought to the denominator, so it's in the correct location of the fraction. So the negative 2 and the x cubed stay on top because they have positive exponents. The negative in front of the 2 does nothing to it in terms of the fraction, so it stays on top. Just means it's negative. So you have minus 2x cubed on top. The thing with the negative exponent gets brought to the bottom, So 1 plus x to the 4th to the positive 5/4 power. Okay? And then that's done. That's it. That's the end of this example. So after this, we've algebraically simplified. The thing that made this one challenging is that we had a radical in the denominator. So what you do, as with all things in calculus, you take your radical, you turn it into a power, and then algebraically manipulate it so you can use the power rule. Okay? So that's it. That's example 14.